Yeah, good afternoon, everyone. Just give it a minute here, but we're about ready to start, and hopefully you all can stay awake after lunch. Pleased to moderate this afternoon's session on high resolution site characterization 2. Just a few things before we start. We have a few forms that we handed out. It's a speaker survey. We do ask you to fill those out, and then we're also kind of just collecting some informal data. So there's 2 forms. If you see, you can fill out for us. And just a reminder, we are streaming this session today. So when there's a Q&A session, we do ask that you speak into the microphone so those who are streaming can hear your questions and responses. So first up, I'm very pleased to, or I guess I should say, I'm Ross Elliot. I'm a hydrologist from Delaware. I'm also the Region 3 Eswamo rep for the LUST task force. And I'm pleased to announce our first speaker today is Corie White. She's a hydrologist from South Carolina. And I don't want to go through her whole biography, but she's a hydrologist of diverse job duties with the assessment, corrective action, and when needed, the regulatory section. Corie has been with the DHEC since June of 2018, when she relocated to South Carolina from Florida, where she worked as a hydrologist specialist at the Northwest Florida Water Management District for over 4 years. Ms. White holds a Bachelor of Science in Geology and Environmental Studies, as well as a Master of Science in Geology from Florida State University.
My name is Corie White. I work at the South Carolina Department of Health and Environmental Control. And today I'm going to give a presentation showing a pilot study in high resolution site characterization at South Carolina LUST sites, lessons learned, and best future uses. We had some contractor input over the last few years that brought high res to our attention. And so we decided to do a pilot study to help test the technology, and as a division, just kind of improve our process and look at different technologies that are available to us. We have some sites through our non-permitted petroleum section and other UST sites where the technology had been used by some of our other contractors, but as a whole, we didn't have any kind of rate. So we did 3 different contracts. The first was to compare high res to traditional investigative methods and see how they compared. The second contract was to apply the high res technologies to the various geologic settings within the state of South Carolina. And then at the end, we wanted to be able to develop a rate structure that would allow our contractors to utilize this technology over the multitude of their cleanup projects. So this is just an overview of the state, the different geologic provinces. The Blue Ridge province is up here. This is the Piedmont, the upper coastal plain, and the lower coastal plain. Through all 3 contracts, we looked at 36 different sites. I'm going to highlight the 3 in yellow that are scattered among some of the different geologic settings within the state. So for our 3 contract structure, we were able to, we set it out with a normal bid structure, and over the 3 contracts, we were able to work with 2 different SC certified contractors. They utilized 3 different HRSC contractors. They were able to test the different technologies that are available for the high res, including the MIP, LIF, and NEIWPCC. And in total, we had, again, the 35 sites. So I'm going to talk about our site for contract 1. It was the Bank of America. It was declared a release in March of 2012. There was an unknown tank status or number. So we were kind of going in blind, and we looked at some of the old Sanborn maps, and it showed that there was a dry cleaner that was adjacent to the site that might be causing some issues. It's located in the Piedmont Physiographic Province. And it was chosen because there was a lot of source area data gaps and there was free product located up gradient from the original known source area. This is a map kind of showing the different points they use. The blue points are MIP points, the yellow is LIF, red is groundwater data they collected from the pre-existing monitor well network, and green is where they did the traditional soil borings to kind of compare to what data they got from high res. So they did 31 lift borings, 22 MIP borings, 1 hydrologic profiling test, 8 traditional soil core borings, and then 16 groundwater screening points. So this is just a collection of the data they collected, showing some of the different MIP points and where the concentrations were. This is compared to where they grabbed soil borings data. So the soil boring they got in this area, they took the sample here, which gave them the highest PID reading. But as you can see, the highest concentration, they kind of missed it. So it came up showing that they had a DRO of 22 and a GRO of 30. So by doing the MIP points, they were able to target better where the concentration was than when they did the traditional soil boring. And then, here they were able to be in the same area they needed to be. Here they got it. Here they missed it. The highest level was underneath. So it was just a matter of comparing those traditional methods to what the MIP was able to show to generate a site conceptual model. And then this over here shows the different, this is the lift profile of where the 2 highest lift profiles were for where the product was. This is the MIP concentration in and around that same area, the SB2 showing where they were collecting it underneath the highest level of concentration. The groundwater screening data they got gave a total of 382 BTECs, and the well that was already present was screened incorporating this area as well as some of this area, but the screening point gave it 382 BTECs, but the monitor well itself had measurable free product in it. And then the deep well is kind of screened right underneath this level and had a low BTEX concentration. So this just allowed us to compare traditional methods to those high-res methods. Groundwater 1 was taken at a depth of 12 to 16 feet, and it only showed the naphthalene and benzene. MW1 was screened from 12.5 to 22.5, and then DW1 was 23 to 28. This is the kind of 2 different maps they were able to make. This map was based off the BTEX concentration contours that they got from the water quality data that they took. And so it shows the majority of a dissolved plume here, as well as a longer plume here. This is the site conceptual model that they created using the high-res data they collected, where it shows that there's an LNAPL plume that goes up into the east, and so it kind of goes up and follows this direction. And this is just inferred that the interior, we didn't have site access, so it was based off of this, and they just kind of drew the contour. And then this is the big MIP concentration that is in this area. And so you can kind of see this is a little bit more narrow than what they were able to discover when they did the actual MIP. Some of the site limitations that we had were access. As I mentioned before, there were a lot of buildings, we're in a downtown area, so they were unable to do MIP or lift points where there were buildings or there were a multitude of utilities as well as roads and sidewalks that kind of prevented them from being able to encroach upon certain areas. They also encountered shallow boring refusal, and there was a lot of downtime due to equipment troubleshooting. So if the equipment needed to be troubleshot or there was an issue with the calibration, there was downtime while the contractor did that. We kind of learned from this site that based on the information they gathered in the LNAPL saturation that it was on the site, that hydraulic LNAPL recovery events such as AFERs would not be effective because of the saturation that was present. And then they identified 2 distinct sources, one being due to solvents and one being due to the gasoline motor oil, with the solvents kind of tying in with what they saw on the Sanborn map, that there was a dry cleaner north of the site. And that it's possible that the diffusion across the road is causing those 2 plumes to commingle. For contract 2, we were just focusing on how it reacted over the different geologic provinces and around the state. We weren't comparing it to traditional models. The site we looked at was Johnny's Truck Stop. There were two releases at the site. One was in January of 1989 from a gasoline UST, and the second was from April 2001 from a diesel dispenser. There was one unsuccessful free product only solicitation. In total at the time, there was over 13 feet of free product in 10 different wells across the site, and it's located in the outer or lower coastal plain. These are all the lift points in blue that they conducted at the site. And there's a few, they did 69 lift points and 7 total MIP points. They also did 6 macro cores for total petroleum hydrocarbons in grain size, and it came back that it was over 60% sand. So the main here, they were focusing, because we knew about the big L and apple concentration, they were focusing on the lift points. And so the red line, I'm going to show the different profile across that red line. The first few shows diesel saturation, and then there's an area where there was some hits, but not really, a little bit diesel, but a little bit not. And then as you moved across the site, you ended up with more intact gasoline and then some of the weathered gasoline. So as you're going across where the diesel I'll show on the next map. So based on that data, they discovered that the green plume was where the diesel was and the blue plume is where the gasoline was. And so the diesel dispensers were over here and the gasoline USTs were up here. And so we were able to differentiate the two different areas. So with this site, we again encountered some issues with property access. There was some access that we had denied where they were okay with us probing and finding some information, but we couldn't put in permanent wells. And then there were other areas where we were unable to fully delineate due to the property access. The area where the gasoline plume was, it is heavily forested. And so there was some difficult terrain and they had a hard time being able to access the land to be able to get the readings they needed. Due to the lithologic conditions, they encountered a lot of refusal. And so they actually pre-probed a lot of the borings to 25 feet before they used the equipment. And they had some electronic conductivity failure in some of the borings. And the site itself was in overall poor condition. There were wells that were unable to be sampled or purged because they had an obstruction. They had IDs missing. So being able to identify the original wells to compare the data was a little bit hard. So we learned that, again, there are the two distinct plumes, the gasoline or weathered gasoline to the north and the diesel to the south. We were able to develop a better site conceptual model so that we can have a targeted cleanup effect. And if we need to treat the two plumes separately, we have an idea of where they are, or we can try to come up with a method that would allow us to treat them both at the same time. For the third contract, again, for this one, we were just doing it for the sole purpose of developing a rate. So we looked at a Flying J. It had 2 separate releases, one in November of 2009 that was a diesel closure, and then one that was in November of 2020 that was a regulatory NFA. So they just removed the tanks and there was no reason to declare a release or separate it out from the original release. That site is still active, so it had an active tank pit. There are 5 currently in use tanks. 2 of them are diesel and 3 of them are gasoline. And prior to doing the high res, there was 1 unsuccessful free product only solicitation. So they were just there to clean up the free product. It is located in the inner/upper coastal plain. This is a image of the site where they did the OIP. So in this contract, they were using OIP and MIP. However, due to some of the refusal that they experienced at the site, they only conducted 24 OIP points. There were no MIPs. And so they just kind of focused on this area and then had the well network surrounding it. Based on the data collected, they were able to create these different diagrams and show where the concentrations of the fluorescent was. The highest fluorescent was just in this small area, but overall the greater than 10% fluorescence, spanned the whole area. And then these just show exactly where the USTs were sitting. So because of the probe refusal, they were pre-drilled again, but this time they only pre-drilled them to 5 feet. And then the MIP deep points were deemed impractical. So we just scrapped those all together. Again, there was some electric conductivity failure and the HPT was only partially successful in 4 borings due to the lithology they encountered. So for this site, it kind of gave us a better visualization of where the product was distributed across the site. And we understood a little bit more about the potential setbacks due to the probe refusal. So it kind of affect what we were going to be able to do out there. And the OIP was able to show the percent fluorescence, but because they have both diesel and gasoline tanks, we weren't really able to differentiate what the product types were. After going through the 3 contract process, we used the first and second contract just to test the high res as a whole compared to traditional methods, and then compare it on the state. So the first and second contract, they involved just running the analysis, and it was bid on a daily rate aspect. So it was based on 250 feet a day. However, we experienced that was actually well below, and they achieved more like 150 feet a day or less than that. So in order to develop the rates, we strictly looked at contract 3. We created a unit rate structure where we were creating a rate that was per foot, which would allow us to pay for the deliverable and compensate for the work that they actually completed. And we just followed our normal in-house bidding process, and our rates are available at our website, and they just kind of show the breakdown of it, which would now allow our SC certified contractors to utilize that technology on any of their cleanups should they choose. And that's it.
We will have a brief question and answer period. Are there any questions for Corie?
What does AFVR stand for?
Aggressive fluid vapor recovery.
Okay.
So it's kind of like a multi-phase extraction is the equivalent. Sorry.
Can you send out the link for that second to last slide?
Sure.
Oh, thank you. Thank you.
Hi, I know you mentioned that on the second scenario that you were in a sandy soil, that it was like 60% sand.
Yes.
In the first scenario, did you do LIF on that one as well?
Yes.
Okay, and do you know what the soil type was as far as grain size on that one?
I don't, but let's see.
I was just curious.
I think it was probably more clay than sand. I didn't really mention it, but it's up in the Piedmont, so you're dealing with like weathered rocks and things like that. So it probably had a higher percentage of clay than sand and silts.
Thank you so much. Yeah, next it's oh, that's mine, sorry. Yeah, next it's my pleasure to introduce Wes Johnson. With over 10 years as an environmental consultant and 13 years as a regulator for the Commonwealth of Kentucky, Wes Johnson currently serves as Columbia Technologies business leader for petroleum, oil, and gas projects in North America. Wes studied hydrogeology and environmental remediation as a graduate student and research assistant at the University of Georgia, and holds a BS in geology and a minor in chemistry from Georgia State University. Mr. Johnson has over 25 years of experience in geology, hydrology, and environmental site management and environmental remediation.
Good afternoon. I will try not to put you all to sleep because I know it's right after lunchtime. So I'm going to quickly reference Todd from the previous site characterization session, who said that basically, I would say the environmental industry in general, but particularly high resolution site characterization, there's a lot of psychology to it. You go into it and you have a site that's been developing over the last 10, 15 years, maybe 10 or 15 remedial actions haven't worked. And then they call you, you go in and you find a pool of NAPL or a pool of high concentrations or high dissolve phase in areas that you didn't expect to find, and then they get mad at you and because you found it, and that's what you're there to do. So sometimes it's a little frustrating, but I thought that was really funny. So anyway, I thought that was a good analogy. Oh, he also said it was a bit like straddling a fence and losing your footing. So oh, before I get started, I also need to say, as was mentioned earlier, I am now with Columbia Technologies, but that's only been for about 6 or 8 weeks. Prior to that, I was with the Kentucky Division of Waste Management, UST branch, for just under 14 years and really enjoyed my work there. Really enjoyed working with the high resolution site characterization, teaching others, learning a lot. And then this opportunity came up with Columbia Technologies. I couldn't turn it down. I'd already gotten accepted to present here. So here I am, all the powers that be graciously allowed me to go ahead and move forward with this. So, that jump forward. So basically, this is going to be kind of a high level flight over a site, but also given a few swoops down to look at some high resolution technologies along the way. You know, what is high resolution site characterization? We'll go over that briefly, give you the EPA definition. Why high resolution site characterization? Go over 2 or 3, maybe 4 methods and tools, and then we'll jump into this Kentucky UST study, look at the application of some of these tools, and we'll end up with, I know this is supposed to be site characterization. I've got some really cool drone footage of the remediation that I won't have anywhere else to share it, so I really wanted to share it here. So, and then we'll go into some lessons learned. All right, I'm just going to read this right out. EPA's definition: high resolution site characterization. Strategies and techniques use scale appropriate measurements and sample density to define contaminant distributions and the physical context in which they reside, with greater certainty, supporting faster and more effective site cleanup. I think scale appropriate is probably most recently what's gotten to me with that. I scratched my head a lot and wondering, what do you mean by scale appropriate? Well, until you do some initial site investigation that's not necessarily high resolution, you don't know what scale appropriate is. So also, as was mentioned in the previous session, all this background data, all this historical data before you get to some of this high res stuff, if that's kind of how the progression of the site works, which is exactly how the site that I'm going to discuss work, it's very beneficial. Don't throw it out. Don't get rid of it. Give it to us. Let us model it. Let us look at it. Let us use it to design how we're going to move forward with whatever high res tools that that are appropriate. And as we continue to move on, these high res tools, the pool, I should say, of high res tools continues to get bigger and bigger, and more technologies that maybe previously we didn't even think would be included as a high res tool for environmental work. Also, as was mentioned earlier, there's a lot of cross-discipline work. As far as, we were talking about geophysics as high res, and then finding these bacterial colonies. And so we've got microbiome and we've got geophysics. And so all these things are playing together. I think we've still got a lot of work to do, but it's a really interesting field. It refers to intrusive environmental site characterization tools and the procedures that go along with these tools and the applications. They're designed to collect real-time, like I said, scale appropriate, site-specific physical and chemical environmental data. I guess we went through most of that. I guess what I'd really like to hit on this one is that these tools are not a replacement for traditional, and I know traditional is a broad category, but they're not a replacement for that. It's a toolbox. You use them all together. You can use some tools for certain site-specific areas, other tools for others, and they're not all appropriate. Like I said, important tools in a toolbox. You don't use all your tools at one time. You don't use a hammer when you need a saw. I know this is all plainly obvious, but I think what's happened is, high resolution site characterization is kind of this buzzword now. And it's like, oh, this is high res and I'm going to do high res here. Well, technically, if you just go out and sample at discrete intervals without any special tools, you're doing high resolution site characterization. And on top of that, you're doing quantitative high resolution site characterization versus qualitative. Like I said, qualitative and quantitative collection and evaluation of data to reinforce a conceptual site model. Typically, you don't see a conceptual site model that is totally in error. Usually, like I said, you have this log of years, maybe decades of backlog data or historical data, and sometimes it's just a matter of putting that data together, coming in with the right tools and jarring it loose and being able to focus your remedial action and take care of things. Covered most of that already. Discrete high resolution site characterization, sampling, and analysis. A lot of what I've done in the past and what I'm about to talk about here for this site is more qualitative, UBOST, LIF, UBOST, electronic connectivity, hydraulic profiling tool, that's more quantitative. But I think we're kind of going using old school methodologies and coming back and going, hey, if we just collect a soil sample every 10 feet down to 50 feet, we're really not getting a really good idea of what we're looking at. So we can use some of these qualitative tools to design our investigation so that we can get some quantitative data, model it, get an idea of contaminant mass, and then go out and pinpoint what we're going to do, maybe a treatment train or just one corrective action technology, but to focus on it and know where we need to head with that. So quantify. I really, as it moves forward, as these tools continue to progress and we learn more about the information that they're giving us, I think the quantification portion is the most important part to learn. Some of the qualitative tools point us in the right direction, but if we don't quantify, we're not going to get our masses right. And if we're doing injections or other things where mass is important, we don't just need to know where it is. We need to know how much of it is there. Very important. Evaluate the mass transport, plume geometry, target our site cleanup, and obviously get to closure. 3 technologies we're going to hit. I'll go through this really quickly. Laser-induced fluorescence and UBOST, the ultraviolet optical screening tool. Let me go through this and then I'll comment on it. The hydraulic profiling tool, which basically takes a look at the overburden relative permeabilities, and electronic conductivity, which helps with the grain size analysis and lithology stratigraphy screening. I spoke probably for the last, I'd say, maybe a year or more, and told people, why do we need to talk about, LIF UBOST has been around forever. EC's been around forever. Hydraulic profiling tool has been around forever. MIP, for an example, it's all been around forever. Why do we need to keep talking about it? And I said, I'm going to quit, going over these things. And I'm just going to say, we implemented this. This is what we found. And they're like, no. As much as it seems like everybody's kind of caught up with the wave, they really haven't. And which is okay. So that's why I'm kind of going through some of this stuff that hopefully it's not too remedial for you all. UBOST measures the laser-induced fluorescence of PAHs and LNAPL, or LNAPL that takes place, that I'll just say inhabits, I'm drawing a blank. The pore space shares it with groundwater, maybe 100%. LNAPL, maybe 50-50, maybe 25-75, but it will get a fluorescent signature off of the UV light that's shown on there, and the UBOST tool can give a reflectance and show what the actual peaks are where you may have some LNAPL, and it will also can give an idea of what type of fuel or what type of petroleum that you are looking at. Hydraulic profiling tool, again, it's basically for unconsolidated materials. It gives us a really good idea of where these permeable zones are that we need to focus on, because in a release, the product is not going to pancake. It's going to basically go as far as its head will push it, and it's going to move down into those more permeable zones as long as there's enough head to push on it, which means it's not going to pancake on top of the water table. It's going to move down into those more permeable areas. You can get effective hydraulic conductivity, relative permeability, and get a good conceptualization of the hydro for the site. Another point with this tool and with the other two tools I mentioned, and probably most of the direct push type tools that we would employ at a site, is they're usually not just one sensor on one probe, usually at least two, maybe three. So you can get multiple streams of data from one push location. Electronic conductivity, again, soil conductivity varies with grain size. The higher the conductivity, the smaller grain size, lower conductivity, larger grain size. This chart shows that pretty well. You've got basically decreasing grain size as you move up here, and conductivity increasing here. So sand is basically, or coarse grain materials is down on this low end, and the conductivity increases as you move up in this direction, as typically, as well as your relative permeability would as well. All right, onto the site. Try to move through this fairly quickly. It's called Sammy's Grocery or Sammy's Market. It's in Sonora, which is in Hardin County, Kentucky. The bedrock's karstic, but it for the purposes of most of this, except for the lithology above it, it's not quite as important, because we didn't even get close to bedrock, which is at about 60 feet. Got a lot of terra rosa geology out there, silty clay. There are also some really interesting areas that it's not rock, but it's well cemented sands, well compacted sands, and when you drill into it, they heave. So it's got it's kind of interesting, low permeability, but large grains. So as we were doing the HPT, which was somewhat unsuccessful just because the things were so tight out there, you either have the clays and the tight stuff, or you've got this really compacted sand material that is really hard for anything to move through. But when you get into it, it really likes to move up the drill rods. We've got, like I said, heaving sands, and we've also got commingled plumes from multiple tank pits, which was a bit of a surprise once I came on board with it about probably 8 years ago. This is the site. This is from 2016. None of this is here anymore. The plume, not even there anymore. So this is, let me start over here. Former UST pit, which was closed, removed in the around 2006. Enormous release, 25,000 plus gallons, lots of dual phase extraction done. I know everybody's familiar with that. That seems to have been the remedy of choice for many years. And then about the time I got the project, they're like, okay, you're just focused on the release from here. We're going to go ahead and close this new UST pit. There's another diesel pit over here. They were installed within the last 5 years, so you won't have any problems. Yeah, right. Just a quick look at the when I'll get to the U-boats data and the footprint, but just so you can see, it's just this small area right here is where we were having product. We had installed a few other wells, and it branched off a little bit in this area. We got some sheen and things like this, but I mean, we're talking half a foot to much less than half a foot in just a very small area. But like I said earlier, the pores don't have to be 100% filled with LNAPL for there to be an LNAPL issue. This is more recent data, and you'll see how it pairs pretty well with the UVOS data that we collected. But this is benzene in soil. So this area right here was where the product was, but this is really lower concentrations here. You move out into here where we have no evidence of NAPL moving into monitoring wells and being very mobile. We've got very high benzene numbers. Similar story, but I think it's even more pronounced with naphthalene. And naphthalene, I believe I said earlier that it is PAHs, specifically naphthalene, are the measurements that we're getting from the laser-induced fluorescence. So the naphthalene portion, if you get a gasoline spill and it's extremely weathered, and you could have all kinds of benzene in it, but if the naphthalene's gone, you're not going to get a signature. Well, you'll see coming up here that the naphthalene definitely wasn't gone. Real quick, Elliot, I'll fly through these if any of y'all are familiar with ITRC. What this shows is, I'm just going to go ahead and pull them all up. So we've got LNAPL wells where the head of the release is pushing down below the water table. Like I said, it's moving under its own pressure into the pore spaces. It's moving into so that it's measurable in monitoring wells, and it's moving, past those locations. It's still actually mobile. The LNAPL head exceeds the formation conditions. A similar condition is here, but it's not migrating. Where you've got the LNAPL equilibrates with the formation conditions. You've got measurable product in the wells, and you've got a significant release, but it's not continuing to mobilize as up here. And then this is probably a hybrid of these two, is what we had at the SAMI site, where we saw some product out there. It wasn't migrating, but we saw an enormous, probably one of the bigger footprints I've seen for a UVOS investigation. It actually took us, well, I'll wait till I get to the overhead, but it took us 3 different investigations because we underestimated it each time. Just a real quick point I want to make here, and I'll move on. So these were some of the signatures that we were getting on the UVOS investigation. Now, typically up until now, or until this investigation, I would have been like, oh man, let's put a well right there. We're gonna get product. We can remove it physically, and we can delineate the plume. Well, not so much. Like I said, we saw a little bit of this, maybe a sheen, maybe a few inches. Mostly, this is what we were seeing. However, the plume was enormous. This is just a good example of how, like I said, the HPT had a little difficulty out there when we were doing dissipation tests, pumping into the aquifer to see, get an estimate of permeability. We were waiting well over an hour. So we were getting really low conductivities. You can see here the HPT pressure. We've got high pressures, very low flows. So we've got somewhat of a very decent confining unit here. And then we've got the EC data over here, where we've got low conductivity, which indicates sands. The sands on this site, very interesting. Like I said, some of them well cemented, low permeability. Some of them, I mean, you pick the stuff up and you could almost like squeeze product out of it. But, oh, sorry. And then also you'll see how the signature on the UVOS correlates with this, basically a floor here for an aquitard-like conditions, and then we've got more permeable zone here. All right, this is the site. We've got a new gas pit, the newer gasoline pit, newer diesel pit, old gas tank pit, which is where all the product came from. So we did an these are all either HPT or UVOS points. Most of them are UVOS points. Didn't take very long to put all those in. Unfortunately, it took a little bit longer because it took us, like I said, 3 times. We went out and said, okay, we're gonna figure out where the, what the extent is so we can drive our investigation a little further. We did an investigation here. Then we did an investigation here. And we said, oh, looks like it's coming from the piping and everything. We moved over here. And even though there weren't any, when we did the closure over here for the diesel pit, we didn't get any, there was nothing to report. It was a clean closure. And that actual closure got NFA, but since we were still out there, we poked around a little bit out there. We got some signatures out there too. Although when we went back and sampled, it was nothing. I think there was some very low level residual naphthalene that was given the UVOS fits. I'm trying to show a point here. We've got these are the hottest areas that we've got. You've got this U-shaped area and the area over here by the newer tank system. And most of this is around all the lines and the discharge system. So we've got RE percentages for the U-Boast 161, 175, 149, 216. Those are all pretty high. I mean, over 100%. So what we need, what I wanted to point out though, is that we've got no NAPL, measurable NAPL, no measurable NAPL. Oh, then we've got a little measurable NAPL here and even less measurable NAPL here. So it goes to show you the higher the readings, not necessarily the more measurable NAPL that flowing to the wells. These are all the points that we had. The data that we collected with all those points, one of the benefits of high resolution site characterization, you can collect all kinds of data points. And I'm just going to run through this really quickly. And you're able to model it, get an idea of calculation of mass. You can also do cross sections, boom, boom, boom. And this is how we designed our final remedial option for the site. We coordinated it off into, I'm going to hurry now because I know I'm running out of time. We coordinated it off into 12 different areas of equal area, determined what the concentration by incremental sampling and laboratory analysis, dosed it with a carbon amendment and bio amendment. And we actually mixed the soil. We dug down, removed the top 15 feet, which wasn't contaminated based on the data. We stockpiled it. And then we mixed from 15 to 23 feet. We mixed the amendment in there. And we were thinking about injecting it. Didn't think we'd get the contact. Definitely didn't think we'd be able to get enough remedial mass in there of the amendment. All right, so I'm gonna have to, oops, let me back up. I'm gonna fly through this pretty quickly, but I just wanted to, it's not playing. I'll move a little bit forward in it. So this is the site. That's where the building used to be. That's where the plume was. We dug down all this soil over here was the top 15 feet. We went down below that, applied gypsum, electron acceptor, and the carbon amendment. It's a big hole. It's a big hole, but do you notice it's a pretty small area? I'm going to jump off of that. Well, now I'm going to jump off of that because I'm running out of time. This is after doing all this and mixing the soil in, mixing the carbon in, mixing the gypsum in. This, and pardon me for this, the last report for this site coincided very closely with me coming over to Columbia. So I know what the map looks like. I hand drew this, I'll be honest. This is what we have left. We've got a little over a part per million in this area right here. But the point I would like to make, and I'm going to just jump very quickly. I'll move through these, goes through some of the lessons learned. But I think what this is really important is we did probably one of the most aggressive remedial actions on this site that I've ever done. Took 2.5 months. We have physically got in there, touched every grain of soil from 15 to 23 feet, made sure that it was homogenized and stirred up with the gypsum and with the amendment. And we've still got concentrations out there. We know it's not, we didn't have to worry about the contact. We know we got it in contact and we've still got concentrations out there. And so when as we move forward, and I know this is a big topic right now, we're trying to clean up to these goals that may not be achievable. We're trying to clean up sites. Do we have any sensitive receptors there? Is there going to be an impact? Do we have any vapor? Do we have any transport pathways that are going to cause an impact to a receptor? What's the future land use look like? Is a plume migrating? This one wasn't. Is it stable? Yes. Is it shrinking? Well, it's shrinking now. We haven't reached the screening criteria yet for Kentucky to actually NFA this site, but it's not going anywhere. And it isn't going to be long, I'm sure. The last point I want to make before I'm done is sustainable. You know, I'm sure those of you who have been in the industry as long as I have are familiar with the fact that we go out and sample, and you can go out and sample for a day and get a pickup truck full of trash just to go and sample. That's not very environmentally friendly. We're going and cleaning up this mess over here and making another mess over here. And that's just one example. So I think it really, this site in general, as I've gone through it, it's an example of we really hit it hard. We spent a decent amount of money. We used a lot of resources. But could we have looked at it a different way and gotten to the same end without having any impacts to any receptors? I'd like to thank particularly Kentucky Division of Waste Management for the opportunity to do all this work, SES, Southern Environmental Services, who helped, GeoProbe, and Dakota Technologies, who did the UBOS work.
We do have a very brief, like 5 minutes for a little question and answer if there's any questions.
Shy.
I know I whizzed through a lot of that, but if you want to ask details, feel free.
You showed the UVOS data in aerial view, and some of the points you said were very hot, 200% plus RE. It's been a while since I've interpreted and looked at UVOS data. Can you remind me or share with us, how can you have over 100% RE? What does RE stand for?
So,
I can't really remember.
No, that's a great question, and I'm sure I glazed over it. RE is reference emitter. So before and after each probe with the LIF-UVOS probe, a reference emitter, which is a petroleum substance. It may be a combination. It may be the actual fuel that's actually on the side. That's really the best way to do it, but it's not always that way. Put it up against the glass, get a reading, see what that is. And then when you probe, the UVOS reading is relative to the signature that you were getting with that reference emitter, that standard, if you will. So if you are, whether you use the NAPA on the site or not, or another type of standard, it's not uncommon, and I know it's odd though, to get readings that are over 100%. I mean, technically that's not possible, but you're kind of comparing apples and oranges, and it, like I said, it's more of a qualitative measurement. So that's how that can happen.
When you were doing the excavation down from 15 to 23 feet, just from the drone footage, it looked like there was a lot of surface water nearby. Was water a factor in that excavation decision?
I thought you were going in one direction, you went in another, but yes, we didn't get any impacts from the actual surface water that was nearby, and that's a good catch. What we did get an impact is that was an extremely wet winter, and we had to get multiple one-time discharge permits in order and pump the water out of the excavation. As I mean, literally, we had yellow iron that was just sinking down into the bottom of the excavation. So it was more precipitation, weather-related water, but not even when we got down below where the water table was, where the measured water table was. It wasn't seeping in like you would think. It was environmental water from precipitation, and not seeping in, something that we had to constantly get rid of.
Thanks for your presentation, Wes. I guess I don't really have a question, but more of a comment. I appreciated your definition of high resolution site characterization and the nebulousness of that definition. But I think it's important to note that in our different toolbox and our different tools, each tool has a different resolution. So to try to like globally say that your your characterization is high resolution is really impossible to say, because it's dependent on the tool and how it's being applied. Right. Even, yeah. So anyway, I don't know, it's just something I've always struggled with, of like, how can we globally define something? And maybe this is a question for everybody of like, that a characterization is high resolution when it really depends on what tool you're using, because they're not all.
And what you're
seeing at
looking
that-
for.
Yeah, and what you're looking for, exactly. So-
And maybe it might even be more appropriate to call it higher resolution, just because the technology has evolved. But good point, very good point.
Thank you. And our last presentation today. It's also my pleasure to introduce Mark Junker, who's been the tribal response coordinator for the Sac and Fox Nation of Missouri and Kansas and Nebraska since 2014. He holds a master's in curriculum with a BA in history and social science from Peru State College. He recently joined ASTM's Moving Sites Towards Closure group to help address the challenges of stuck tanks in Indian country. He created both the SAC Fox Emergency Response and Multi-Hazard Mitigation Plan, and in 2020, he co-authored the Solid Waste chapter, The Status of Tribes and Climate Change Report. Mark also serves on the Tribal Infrastructure Task in addressing barriers to sustainable solid waste programs and participates in the Tribal Superfund Working Group. ITRC Regulatory Council as a member of the Advanced Characterization Tools team. He currently serves as a chair of the Tribal Waste and Response Steering Committee and is active in climate adaptation, emerging contaminants, food sovereignty, sustainability, and softball.
Oh, good afternoon. Man, there's a lot of science today. You guys are really good at science. When I arrived at the Sac and Fox in 2014, most of our problems dealing with petroleum releases were all surface releases. The underground storage tank program was something that was I would not know anything about for another year and a half or so. That all changed very quickly. The Columbia Technologies was a big part of the high resolution characterization at the site that we had. And I thought I'd give you guys a little bit of a breakdown of just where the Sac and Fox came from and where they're at now, in terms of the geographical moves that they've had over the past 300 or 400 years. The original homelands of the Sac and Fox are around Detroit and this area here. They're a Algonquin speaking tribe. By the early 1800s, they'd made a treaty with the United States that gave them that tan shaded area about the size of Kentucky. And after the Black Hawk Wars, they were given 6 counties in Northwest Missouri. And today they occupy about 25 square miles on the Kansas-Nebraska border. Some of you may be familiar with Chief Black Hawk or with Jim Thorpe, Black Hawk. Again, his name is associated with the Chicago Blackhawks hockey team, the Atlanta Hawks basketball team that originally came from St. Louis. There's even a town called Jim Thorpe about 300 miles east of us here in Pennsylvania. So that's where we're located now. And there are 3 distinct branches of the Sac and Fox Nation. The Meskwaki, which is more of the Fox side of the tribe, is located in Tama, Iowa, up by Des Moines. And then the largest group of Sac and Fox of Oklahoma is headquartered in Stroud, Oklahoma. This is a horror story. Like Dracula, it sucked the blood out of me. It was a nightmare on Highway 75, not Elm Street. Sometimes we froze our butts off, like in The Shining. Our head spun around quite a bit, like in The Exorcist, and just like Jason, it kept coming back. So this is the site where this particular nightmare took place. And it started on July 20th, 2015. with an alarm going off. Amanda, who is our manager at the site, got a water alarm. And very shortly thereafter, she checked on the alarm, shut down the pumps, and about 7 cars that were under the canopy getting gas at that time wouldn't stay started. We had 7 vehicles with water in their gas, and that became very obvious. What wasn't obvious is where's the water coming from, and that's a problem that plagued this investigation from the very start and took us a long time to figure out. The actual reservation is about 20 miles from the site of our truck stop. It's actually located within the entire confines of the Kickapoo Reservation. And so it's 21 miles as the crow flies, about 30 miles to drive there. So our response is generally around 45 minutes if they let us know right away. In this case, they really didn't let the environmental department know for a couple days what was going on. In the meantime, the fire marshal, the police department are all out there. I get the call late on a Wednesday afternoon, several days after this has happened. And one of the first things that I'm told is, we've got to do a conceptual site model. And very quickly, they started pulling water out of the tank. 19,000 gallons by July 22nd. It didn't take long for this particular frac tank to fill, actually, and I think it holds around 30,000. But so on July 22nd, we're recovering free product. And when it comes to conceptual site model, it's really kind of interesting. The diagrams and charts that are being put out, I think it was Arthur C. Clarke that said any technology sufficiently advanced is going to appear like magic. You guys are like magic to me, because this is what I came up with. This is just my using some drawing tools in Microsoft Word to put together a Google map to begin to understand what this site is about. And so we've got a tank pit down at the bottom where we're recovering fuel. That frac tank and the red triangle is where we're putting it. And we've got some monitoring wells that we're going to put in. It looks like it's just one tank, but again, we don't really know what the cause is. So we bring in a camera to scope the tank. And so again, on July 22nd, we get this picture, a pile of gravel sitting in the tank. And again, what does that mean? Obviously, there's gravel from the tank pit coming in. And so we need to figure out what we're going to do with it. By November, and again, a lot of this is going really slowly because the tribe's never done this before. I've never done this before. I'm not really good to do anything without the tribal council telling me to do something. They're looking for recommendations for me. I'm talking with EPA, trying to figure out what I should do next. We do have a geologist on scene and they're taking samples. We've got 4 temporary piezometers, and that's in November of 2015. In February of the next year, we do have a big sit down with the insurance companies, the remediation specialists, and all tribal council members are there. And so we're going to plan to remediate or repair or abandon the tank. While the site's open, we're going to deal with any free product, get that plume defined. And initially we start out with 5 wells, and then we said we can maybe cut it back down to 2. Again, the insurance company is dictating a lot of the decisions that we make. By July 11th, 2016, we've got 3 full frac tanks. They've all got quite a bit of product in them. I forget the exact number, but I think it was eventually determined about 5,000 gallons were released. And we're covering quite a bit of it with these frac tanks. We wind up sending nearly 100,000 gallons all the way to Indianapolis at $1 a gallon. So again, it's pretty pricey. But then finally on July 11th, we've got everybody's permission. The tank manufacturer wants to be there. Everyone has told us from the very beginning that this is a Xerces tank. And so Xerces has arrived on the scene. They're not, we're not going to do anything until they're there. And so we cracked that last bit of concrete with the tribal council standing by. They're going to be ready to make a decision. And we see this. If any of you guys are familiar with Xerces tanks, they're red. This is not a red tank. And so the guy from Xerces, he basically got in his truck, said, "Not my monkey, not my circus." And we were left to figure out what to do. I had been told from the very start that these were Xerces tanks. They'd been installed back in 1999. 2 days after we discover this shows up on my desk. They're pictures of the install from back in 1999 during the period of that great tank yank, when everybody was trying to get it in. And what we had done is ordered them from Xerces, and Xerces said it's going to be 6 months. And the tribal council at that time said, we can't wait. Let's get anything, put them in the ground. So by December 12th, it's really costing business to have this tank shut down. And so we're beginning to land farm some of the soil that's immediately adjacent to the tank pit. And on December 15th, we pull it out. And we can see that it was a catastrophic failure of the tank. And so the water was rushing in there. The water table was high. That explains it, but it's obvious delamination. We've had all kinds of experts looking at it. We do install new tanks, but as you can see, there's quite a bit of excavation that's been done. By February 10th, we're throwing in a brand new diesel tank. And so brand new tank pit, old tanks being taken care of, kind of put out there. And between March of 2017 and February 2018, we've got 13 new wells, bringing our total to 18. We're looking at some vapor intrusion. We're also trying to get a better picture of the geology and groundwater. And then we bring in Columbia Technologies with some of their stuff. And we drill 25 new boreholes to get a picture of the plume and any residual product. And we do that over the course of 3 days. And one of the nice things about this is we're getting some real-time data. We can go to the van in the middle of this miserably cold March day and take a look at the site, the data coming back, and deciding where we're going to put the boreholes the next day. And so that was really pretty critical when we did this, because we want to try and paint a really good picture of what this plume looks like. And the other thing too is we can go back to their website. It's accessible. I can look at it pretty much 24/7 on any device and pull up specific data if it's of interest to me. So again, this is like the benzene progression over the course of a couple years. Gasoline range organics, again, starting in August of 2018, January 2019. To May of 2019, May of 2020. We weren't really too organized, and having never done this before, the schedule for monitoring was supposed to be quarterly. That never quite happened. We might have done 4 quarters in a row. And now we're actually to the point where we're just monitoring semi-annually. And this is some of the pictures that we're able to present as we look to further clean up the site and characterize it, but definitely 3 distinct areas. And again, the data that's being brought forth is really pretty useful, especially if we choose the bioremediation route. I mean, it's going to give us some pretty obvious points to begin bioremediating. And it's also giving us a real clean picture of the soil, because what we have here is, a depth of about 12 to 18 feet of where the product's at, and it's trapped between clay layers. And, they told us the plume is moving slowly between 50 and 200 feet a year. Well, that's a pretty wide range in my book, but it also brings in the possibility of maybe doing some type of membrane to prevent it from migrating any further east. But we do have monitoring wells set very far east of the site, and we've had no detect on those. So the plume is for all intents and purposes right now very stable. We don't have any receptors. We are doing vapor intrusion monitoring as well, and haven't had any of that. Vapor intrusion inside a truck stop, ambient air is worse than any vapor intrusion you're ever going to have. And we can tell even in the initial LIF sessions that we did, that some of the product had already been attenuating. And so we do have 4 potential remedies. We could excavate the entire site, shut down the business for a month or so and move all that dirt. And actually probably wind up creating more pollution. I think Wes did a great job of, expending resources to clean it up. We'd actually probably be creating more problems than we solve by digging up all that dirt. The permeable reactive barrier, I kind of like that idea just because it kind of sounds cool. Bioremediation is another option. Again, I really appreciate some of the comments people had in earlier sessions about the nature of the bioremediation. And the thing that's happening right now is natural attenuation. And to me, it seems the least impactful of all the possible solutions. In the meantime, we are kind of refitting the truck stop there. And we'd have a bit of a tanks graveyard off to the east of us. But that's all I have for you all this afternoon.
Are any questions?
That was a fantastic presentation. It was very obvious early on you had some issues with your insurer, that they cut you from 5 to 2 monitoring wells. I'm not really sure, but it sounds like maybe now you've gotten them on board and they're stepping up to the plate to do some of the things that need to be done to assess and clean up the site. Is that accurate?
They basically settled. We're on our own now. Yeah, we're and our site's self-insured now too, by the way, so that makes it tough.
Hey, I have a question from Zoom. Billy Willard from BADQ would like to know who the tank manufacturer was.
They're out of Tulsa.
Has anybody looked at why the tank failed?
Yeah, we have. We had some really smart people down there looking at it, performing all kinds of microscopic studies on the actual fiberglass on the tank, and it delaminated probably due to too much sand in the fiberglass. And that's always an issue, I think. Would this have happened without the ethanol? You see how it impacts fiberglass, and I don't know if we necessarily looked at the ethanol impact, more of just the composition of the fiberglass.
Thank you again.